Hello students, welcome to grade 12 chemistry revision lesson on fundamental concepts of chemistry. In our today's lesson, we will learn about applications of chemistry in everyday life, definition of chemistry, and measurements and units in chemistry. At the end of this lesson, you will be able to list applications of chemistry, distinguish between physical and chemical changes, give examples of intensive and extensive properties, interpret the given data in terms of precision and accuracy, tell the number of decimal places, tell the number of significant figures. Students, if you are ready, then we will get started. Chemistry in everyday life. Almost all things around us involve chemistry. Now, what are the applications of chemistry in everyday life? These are some applications of chemistry. Chemistry is an aid to agriculture. Chemistry has been successful in the production of fertilizers and pesticides, which includes biocides, insecticides, herbicides, fungicides, and so on. Chemistry has also a major role in the production of preservatives. Preservatives are chemicals which delay the growth of microorganisms. Yarn and dyes are also applications of chemistry. Yarn is a fiber which is used to make a variety of clothes. Cement, plastics are also applications of chemistry. Chemistry is used in synthesis, in making drugs and medicine. Dynamite and firework are applications of chemistry. Dynamites are explosives which mainly used in mining, construction and demolition industries. Petrochemicals such as diesel and petrol are applications of chemistry. Therefore, chemistry enables us to make all materials. Definition of chemistry. What is chemistry? This is a very good question. Chemistry is defined as it is the science that deals with matter and the changes that it undergoes. Chemistry is the study of composition of a matter, structure of a matter, and properties of a matter and of the changes that occur in matter. Chemistry is quite simply the study of matter. Matter is anything that has a mass and takes up space. Changes are of two types, physical change and chemical change. What is the difference between chemical change and physical change? Chemical change, more commonly known as chemical reactions, are processes whereby one substance is transformed into another as a result of combination or dissociation of atoms. Physical changes differ from chemical reactions in that the involved substances do not change their identities. In physical change, there is no new substance formed. Each retains its composition. These are some examples of chemical and physical changes. Change of states is an example of physical change. Melting of ice, freezing of water, evaporation of water, dissolution of salts and water, formation of solution is an example of physical change. Mixing or separating iron with sand, formation of cloud, sublimation of iodine. Again, this is change of states. All these are examples of physical changes. Chemical changes, oxidation of substance, example burning, rusting. We know that water and oxygen jointly oxidize iron and convert it into rust, is an example of chemical change. Is chemical process, chemical reaction. Fermentation, souring of milk, digestion, decaying of food, and heating of sugar are examples of chemical changes. Physical properties. There are two kinds of physical properties, namely intensive and extensive physical properties of a substance. Extensive properties are those properties which depend on amount of matter. For example, properties such as thickness, weight of the substance, diameter, height, mass, electrical resistance, volume, area, and so on are extensive properties of a substance which depend on amounts of matter present. The other type of properties of a substance is intensive property. Intensive properties are those properties which do not depend on amount of matter present. Properties such as specific gravity, freezing point, melting point, evaporation, odor, color, taste, solubility, hardness, compressibility, conductivity, and malleability are examples of intensive physical properties of a substance which do not depend on amount of matter present. Measurements and units in chemistry. Measured quantities without units attached to it is meaningless. For example, the distance between Addis Ababa and Awasa is 275. Now, this statement is meaningless unless units such as kilometer, meter, or miles are attached to it. Therefore, measurements must be expressed both in numbers and units. Conversion factor. Conversion factor is a fraction whose numerator and denominator are the same physical quantities and expressed in different units. Conversion factor equal unit of desired quantity divided by unit of original quantity. For example, convert 75 nanogram to milligram. You are asked to convert 75 nanogram to milligram. What do you do? Good. A. 75 nanogram times quantity of desired, which is milligram. Unit of desired quantity is 10 raised to minus 6, 10 raised to minus 6 milligram, divided by unit of original quantity, which is nanogram, 1 nanogram. Nanogram will be cancelled by nanogram. Now this is the same as 75 times 10 raised to minus 6 milligram. We can write this as 7.5 times 10 raised to minus 5 milligram. B. Convert 6.75 meter cube to microliter. 6.75 meter cube times unit of desired quantity, which is microliter, 10 to the power of 9 microliter, 10 raised to 9 microliter, divided by unit of original quantity, which is meter cube, 1 meter cube. Meter cube will be cancelled by meter cube. Now this is the same as 6.75 times 10 raised to 9 microliter. Students, let us try this exercise so that you can practice what you have just learned. A. Convert 1.2 centimeter to micrometer. B. Convert 100 nanogram to microgram. You have 3 minutes. Good. Let us do together. M. Convert 1.2 centimeter to micrometer. 1.2 centimeter times unit of desired quantity, which is micrometer, 10 to the power of 4 micrometer, divided by unit of original quantity is centimeter, 1 centimeter. Centimeter will be cancelled by centimeter. Now this is the same as 1.2 times 10 to the power of 4 micrometer. B. Convert 100 nanogram to microgram. 100 nanogram times unit of desired quantity is microgram, 10 raised to minus 3 microgram, divided by unit of original quantity is nanogram, 1 nanogram. Nanogram will be cancelled by nanogram. Now this is the same as 100 times 10 raised to minus 3 is the same as 0.1 microgram or 10 raised to minus 1 microgram. Good. Uncertainty in measurements. in scientific work, we recognize two kinds of numbers. These are exact and inexact numbers. Exact numbers are numbers which have defined values. Inexact numbers are numbers which have some uncertainty. Numbers obtained by measurements are inexact numbers. Therefore, what are the causes of uncertainty? There are many causes of uncertainty, but the most important are usually: one, the person doing the measurement is one cause of uncertainty. Two, the measuring device, the device itself is cause of uncertainty in measurement. Three, the environment where the measurement is being made is also cause for uncertainty. Four, variabilities in item being measured. These are some causes of uncertainty. Therefore, numbers obtained by measurements are always uncertain. They have some uncertainty. Precision and accuracy in measurements. Precision and accuracy are terms which are used to express uncertainty of a measurement. Accuracy is the extent to which a measured value coincides with a true value. Precision is agreement or closeness among several measurements of the same quantity, the same data. For example, the accepted or true value of the density of water is 1 gram per milliliter. This is true value or accepted value of density of water. Two students A and B determine the density of water in gram per milliliter. Student A in his or her trial 1, 0.91 gram per milliliter. In the second trial, 0.92 and so on. Average values of measurements of student A is 0.90. Student B in his or her trial 1, 1.10 gram per milliliter. In the second trial, 0.99. Average value is 1. Now, which student made an accurate measurement? Which student made a precise measurement? Good. The average value of measurements or data of student A, student B is 1. Now this coincides with the true value, the accepted value. Therefore, student B made an accurate measurement. You see, the average value, which is 1 gram per milliliter, coincides with the true value. As we said, accuracy is the extent to which a measured value coincides with a true value. Measurements of student A are close to each other than measurements of student B. Therefore, data or measurements of student A is more precise than measurements of student B. Hence, data of student A is more precise than data of student B. Decimal places. Decimal place refers to numbers of digits to the right of the decimal point. Number of digits to the right of the decimal point. For example, a number 0.087 is a number given to 3 decimal place. This 0 is the first decimal place. 8 is the second decimal place. 7 is the third decimal place. Therefore, this number is a number given to 3 decimal places. Rounding off means finding a number that is closest to a given number but with a fewer digits. How can we round off a number? Rules for rounding off a number. Rule 1. If the digit to be removed is less than 5, the preceding digit retained. For example, 8.234712, round only to 2 decimal places. Now the number to be removed starts from 4. This is less than 5. Now the preceding digit is retained. Therefore, this number is reported as 8.23 to 2 decimal places. Rule 2. If the digit to be removed is greater than 5, then we add 1 to the preceding digit. For example, 6.1264 round to 2 decimal places. Now the number to be removed starts from 6. 6 is greater than 5. We add 1 to the preceding digits, and this number is reported as 6.13. 3. If the digit to be removed is 5 and no other digits follow the 5, then the preceding number increased by 1 if it is odd. 2. Remains unchanged if it is even. For example, 8.165 round off to 8.16. Why? Because the number to be removed is 5 and no other digits follow 5. The preceding digit is even. It is retained. Now this is reported as 8.16. Being 8.175 round off to 8.18. Again, the number to be removed is 5 and no other digits follow 5. The preceding digit is odd. We add 1 to it and is reported as 8.18. Note, if 5 is followed only by zeros, if 5 is followed only by zeros, the leftmost digit is unchanged. But if the 5 is followed by non-zeros, the final digit is increased by 1. For example, 17.6500 rounds to 17.6. You see, the number to be removed is 5. Now this 5 is followed by zeros. The preceding digit retained and reported as 17.6. But 17.6513 rounds to 17.7. The number to be removed is 5 and is followed by non-zeros. We add 1 to the preceding digits and this number is reported as 17.7. Students, let us practice these questions. You have 3 minutes. Welcome back again, students. How did you do it? Good. Let us do together. M round 45.795 to 2 decimal place. The number to be removed is 5 and no other digits follow 5. We add 1 if the preceding digit is odd. Therefore, this is reported as 45.80. 80. B round 45.785 to 2 decimal place. The number to be removed is 5 and no other digits follow 5. The preceding digit is retained if it is even. Now this is reported as 45.78. 45.78. C round 45.76500 to 2 decimal places. The number to be removed is 5 and is followed by zeros. The preceding digit retained, and this is reported as 45.76. 45.76. D round 45.76514 to 2 decimal places. The number to be removed is 5 and is followed by non-zero digits. We add 1 to the preceding digits and is reported as 45.77. 45.77. Significant figures. Significant figures are those digits which correctly indicate the precision of a measurement. There are 4 significant figures in 20.44 and 66.46 centimeter. It is important to note that all digits of a measurement except the zero are significant. The zeros of a measurement, on the other hand, may or may not be significant. This depends on their position in the reported numbers relative to other digits and also to the decimal point. Rules to determine when a zero is significant. Zeros become significant, 1, when they appear between other figures. For example, 1.002 gram has 4 significant figures. These 2 zeros are significant because they appear between non-zero digits. This number has 4 significant figures, 1, 2, 3, 4. Zeros become significant when they lie to the right of the decimal point. For example, 140.00 has 5 significant figures. These zeros are significant because they lie to the right of the decimal point. Zeros may or may not be significant under the following conditions. 1. A zero is not significant if not preceded by non-zero digits. Example 0.0123. This number has 3 significant figures. These zeros are not significant because they are not preceded by non-zero digits. If the zeros follow non-zero digits, there is ambiguity if no decimal point is given. For example, how many significant figures are there in 52100? How many significant figures are there in this number? It is ambiguous because final zeros are always ambiguous. Here it says, if the zeros follow non-zero digits, there is ambiguity if no decimal point is given. Final zeros are always ambiguous if there is no decimal point. Example 2. How many significant figures are there? M in 204 kg. Three significant figures are there in this number. Three significant figures. This 0 is significant because it lies between non-zero digits. 0.004 gram. This number has one significant figure. Zeros are not significant if they are not preceded by non-zero digits. Therefore, these zeros are not significant. This number has only one significant figure. 0.0802 centimeter. This number has three significant figures. These zeros are not significant because they are not preceded by non-zero digits. 90560 Newton. This is ambiguous. As we said, final zeros are always ambiguous if there is no decimal point. Ambiguous. Ambiguous. Students, in our today's lesson, we discussed applications of chemistry. As we said, chemistry enables us to form all materials around us, to make all materials around us. We defined chemistry. Chemistry is the science that deals with matter and the changes that it undergoes. We discussed properties of matter. There are two physical properties of a matter. These are intensive and extensive properties. We learned precision and accuracy. We learned decimal places. We defined significant figures. This brings us to the end of our today's lesson. Until next time, goodbye.